Hi Professor, I am Venkata Krishna Pedimari, currently pursuing final semester of my Masters in the Department of Electrical and Computer Engineering at Texas A&M University. The topic I have worked upon for the term paper is the network information flow. Before we move on to the topic, I would like to discuss in brief on the concept of flow network, which is actually dealt throughout the paper. So a flow network is a directed graph where each edge has a capacity. So it's essentially a combination of the dots or the vertices called the nodes and the lines joining those dots and the vertices, which are called the edges. So in this paper, the notations that are used are G, the directed graph. Okay, directed graph is essentially the total picture that we see on the left. G is the directed graph, V the set of all nodes, and E is the set of all edges, and I, J is the edge from node I to node J. The primary areas where this flow network finds its applicability is in the domains of networking, network coding, and pipe analysis. So since it has got some relevance to my domains of and areas of interest in as computer networks and network coding, I have chosen to work on this paper. In this paper, the primary problem that has to be addressed is to deal with the admissible coding rate region. Admissible coding rate region is essentially the set of all allowable capacities or the set of all the edges that have allowable capacities, and related to that, admissible is something which is allowable. So here for that, the scenario that has been considered is one source to multiple destinations scenario, and we are assuming that the sources are mutually independent and multicast to certain destinations. So this is the primary situation that is actually dealt in this paper, and this notion has been extended to multiple sources as well, but however, due to some proofs provided by the author, it is detected that the only through coding techniques like network coding, the bandwidth can be efficiently utilized and throughput can be improved significantly when there is a multiple source scenario. So we cannot treat information as a fluid, okay, for multicasting from multiple sources. So this is what the paper in summary conveys about. Now, in this paper, the flow network parameters that are considered are the X sources X1, X2 and Xm, which are mutually independent, and the scenario is always one source to multiple destination scenario, and there is and the source is generated at node A of I and is multicast to node J for all J belonging to B of I. So A is the set of all source nodes and B is the set of all sink nodes or the destination nodes. Okay, and one with a better example can be understood at a later point of time. And the mappings A, B and H. H is the information rate of the channel. So information rate of the particular edge. So here now every node can act as a switch where the information can just be passed on or replicated, or it can be act as an encoder. So that has some importance because it need not restrict its function to just a switch. So admissibility is something which deals with the set of allowable capacities. So that is essentially the concept of admissibility. A vector is admissible if there exists a coding scheme satisfying the set of multicast requirements such that the coding rate from node to node is less than or equal to Rij. So Rij is considered to be the capacity of the link, the maximum, the possible thing that is actually possible from node I to node J. That is the capacity of the edge I to J, and this is there A vector which is actually decided by a particular coding scheme, okay, will be considered as an admissible coding scheme that can allot capacitances in a right way if, okay, the coding rate from node to node is less than or equal to Rij. So now the thing is, we need to find the admissible coding rate region, okay, for the set of all admissible R for any graph G, and of course the multicast requirements, the source set of sources A, the set of destinations B and H, which is the information rate. So now we deal with the example scenario of a multi-level diversity coding system where x1 and x2 are the mutually independent information sources which are being passed on. As we can see, the mappings for A and B would be A of 1 equal to 1, A of 2 equal to 1. So source A of source 1, the source of node x1 is 1, node 1. Source of x2 is node 1. So this is the figure below represents the graphical model, so which essentially covers all these aspects. So as long as there is no connection between the encoder and the decoder parts, okay, we assign the capacity Rij to be infinite, as it is a straight connections. We are just dealing with the straight connection. Now we move on to the maximum flow minimum cut theorem. In this for this situation, for this problem, okay, there is a single source S considered and there is a multiple sinks T1 to TL that are considered. The information source is generated at node S and multicast to the nodes. So here the primary rules that are to be focused are, we can consider this as a one source to L sync problem, and F is a flow. Flow is essentially the value of some capacity, certain value that is allocated to a given link by a certain coding scheme. That is the flow. It has to obey the following law, that flow into the node should be same as the flow outside the node, and that is the primary criteria that has to be done, and that Fij can be less than or equal to the Rij, which is the capacity, the maximum possible flow that can actually be possible from I to J. So we move on to the single level diversity coding system, where we have x1 is the only information source and the information rate is H. So the sum of coding rates, the main theme that is addressed here is the sum of coding rates of the encoders should be at least H. So R1 plus R2 greater than or equal to H, R2 plus R3 greater than or equal to H, R1 plus the other summations have to be greater than H, where Ri is the encoding rate of source I. So this has to be done because the decoder has to reconstruct the source X. For that to happen, these conditions have to be satisfied, where H is the information rate. From the graphical theory perspective, the value of maximum flow from S to T1 is to be greater than H. So that is how we interpret from the graphical point of view. So here, to illustrate simple example of max flow and min cut, let us here the max flow, min cut, the maximum flow, the simultaneous number of bits that can be sent across all the three is 2, because we can see the shortest path from S to T1 is 2, from S to T2 is 2. So we can essentially map that path. Suppose, let us say there is value 2 here and 3 here, then the shortest path will be 2, because it is the maximum flow and minimum cut theorem, where it is taking the minimum value into consideration, so that will be the number of bits that can be sent simultaneously. And in the paper it is shown that network coding would benefit such kind of network scenarios, and it has been proved that with network coding the bandwidth utilization and throughput have improved significantly. So we move on to the primary result of the paper. So here a coding scheme alpha code is considered which has a tuple RHG to deal with. There are a certain set of conditions that are defined, okay, and these conditions are actually pointing out to the definition of alpha code, and the alpha code, okay, is considered to be admissible if the conditions given, okay, here are satisfied. These two conditions. So this is the primary condition, and these are all the set of tuples RHG that satisfy this condition. And it is also assumed that there is no edge from node other than S to S, and there is, because they don't contribute to maximum flow, and there is no edge from a node to itself. And on the other hand, we consider a directed graph G from V to E, from the vertices V and edges E, okay, where we have the condition discussed earlier that the sum of coding rates of encoders is at least H. We consider that set to be R star and the set of all the tuples to be RHG. So this paper primarily proves that RHG is equal to the R star HG. So this is the primary summary of the paper, and it is eventually proved that R is subset of R star and R star is subset of R. R star subset of R will imply the admissibility part of the proof. So essentially it is proven to be equal to that one. So from the course point of view, I can see there's certain linkage because we deal with the case of one source to one destination and how to handle the capacities. In this paper, we see a single source to multiple destinations scenarios where we are dealing with how to handle capacities in a real-time scenario. That in that aspect, it proved to be very much useful in understanding this paper. And this paper also highlights the aspects of replication and bandwidth utilization. Okay, and how coding techniques like network coding would actually help in achieving a better throughput and bandwidth utilization. So throughput and bandwidth utilization, considering these two factors into account and also considering some realistic scenarios, actually helped in gaining a better understanding of the course concepts and apply my course concepts in a better way. And we also it has to have some background of source and channel coding. So the example that is illustrated here is for the main theorem, where a cyclic graph is taken with convolutional code, and with mathematical induction it has been shown that, okay, since these operations, all the 11 operations are valid for time k minus 1, it is also valid for k. So that proof has been shown. The encoding rate for this case is assumed to be 1, and the example, as we can see, considers the multicasting of x0, x1 and x2. So at the end it is shown that the coding scheme can multicast x0, x1 and x2 to all the sinks. Finally, for future scope, this has some applicability, okay, for multiple sources scenarios, okay, in the domain of video conferencing, which can be treated where we treat it as a merge multiple sources into one and treat it as one source to multiple destination problem. It is also finding applicability in symmetrical multi-level diversity, but it has a limited scope as we cannot have a fluid assumption valid.